All right, moving into Objective 8, or not Objective 8, but Module 8. And in this module, we are looking at GIS. So we're actually getting into mapping. So your project for this one is you're going to probably spend more time on the project than listening to me. So because I want you to create a map. I want you to apply what I'm talking about here and create it and represent your map in a way that I can read it. So I'm going to be covering a little bit about all of this. So you're going to find that creating a map has a lot of components to it. And I mean, just looking past the complexity of software, there is a lot of layers, there is a lot of interpretation, there is a lot of like adapting of the map as well. So there is a lot of work that goes into creating a map. So what we're doing here is a very simplistic map, a very beginner style map that is like generally used across any beginner mapping course. But I want to introduce some of the concepts behind it and what you can do about it. So the first one is list data collection techniques. So there's lots. We can go on and on and on. Everything from conventional surveying to just doing research to like surveys to going online and looking up tables of information to like everything. So any kind of map that is created has to come from some sort of data. Now, it can either be primary data that you have collected yourself, or it can be secondary data, which is data that it comes from somebody else. And that's where like a lot of research or like tables of data kind of come in. The the cool thing about data collection is that because there's so many different ways of doing data collection, that it really comes down to the scope of your project, right? Like there's no point in putting together a survey for people who live in an area when you are trying to represent the topography of the area. The survey is not going to help. But if I was to be doing something that, I want to find out how the people like their water at the bottom of the hill, like their drinking water at the bottom of the hill versus the top of the hill. And the topography is important because I'm looking at the slope of the hill, but I need the survey because I need to find out, does the drinking water taste vary between the people? Like, and their tastes of the water. Do they notice a difference between it? So that's where that mapping component, like surveying a survey would come in. So again, it really comes down to your scope. So you really have to define your scope. You always need to discuss to like totally define your scope before you get jumping into mapping, because your scope can become huge. So there's a huge amount of project management that happens when you're doing this. So that's Objective 8.1. I'm going to move into Objective 8.2 because it all relates basically up until 8.3. So 8.2 is applying map elements to create a formal map. These are the things that I expect to see on your map. So when you go through and you're doing your project, your mapping project, and you are finished up the actual map itself, which is like really the data of the map, these are the things I want to see. So first of all, you need a title. Everything that you do usually has a title to it somehow. So put the title on there. Make sure the title is general, but it's also descriptive. So don't just be like Maps 204, assignment 8 or 9. This is 9. Don't say that. That doesn't help at all. I want you to tell me what you are mapping. Like, tell me the area that you're mapping, that location. Maybe you're doing a local park in a subdivision. So, like, for example, I might be like local varsity park features or something like that, right? So that would be a title. Author, you are the author. Make sure you put your name on it. The reason I want you to put your name on it, and actually on the map itself, so on the map layout, I want you to put your name on there because it is for copyright purposes. Because if you don't put your name on it, somebody else can take it and copy it, and then they have it. So if you put your name on it, you are now the owner of that map. And like, I mean, obviously companies, it's a little bit different when you work for a company, but even then, they want to know who in the company made that map. And so it's either to give you a bonus because it was an amazing map or to take you to court because you did a terrible job. So, but you always need your name on there. You also need to include the date you created the map. So that it could take you months to create a map. And that's okay. The day that you say publish is the day that map was created. Okay? So that's essential to keep in mind. You also need to tell me where the source of the data you got is from. Okay, so if you got some information from the internet, tell me that. If you got it from my course, tell me that. If you got the data from, ArcGIS Online, or you got it from a satellite image, or you got it from somewhere else other than your own data, you have to put it on there. Even digitizing. So when I get to digitizing, which is like the next objective, if you take a satellite image and you draw your own map with it, and then you take away the satellite image, guess what? You still use the satellite image, right? You use that satellite image to be able to create your map, so therefore you need to say that you have used that satellite image to create your map. It's really, really important. Otherwise, it is a copyright liability, and therefore they could take you to court. And so you don't want to do that, like, because it's information, IP. It's IP information, so just like an intellectual property rights to it, right? So if you don't include the date and your name, or sorry, the data in your name you need for your own copyright, but the source of the data, if you got it from somewhere else, you need to state that. There's another reason that you should do it as well if you get it from somewhere else. If you're getting your data from somewhere else, what if there was an error in that data? What if there was? Now you just took the error in that data and you just put it on your map. Your client finds the error and comes back at you. They're going to take you to court. And then if you wanted to try to like say, well, no, it's not my fault, it's their fault, but you didn't put their information on there, you have no right to be able to go back to them because you can't prove that you used that data unless it's there. So, and at that point, you're safe, right? So it's a liability thing, so please make sure that you always put the source of the data on your map. It's actually considered plagiarism at SAIT. So I'm going to enforce that. I'm going to say it again. Make sure you source your data. Tell me where you got your data from, because otherwise it's plagiarism. Okay? Really, really important, that one. So the other thing, though, is what if you create your own data? So there's certain things that you can do with your own data. Like if you went out and just observed on a day and you came back and you put some information in there, you're going to say data collected through observation. Easy. If you had to use a handheld GPS, which is one of the things that you guys are going to be doing, you are going to tell me the day you went out to collect the GPS data. You are going to tell me what did you use to collect the data. Did you use your cell phone? Did you use an app in the cell phone? If you used an app in the cell phone, you state what the app was. You don't have to tell me what kind of phone you used. You're certainly welcome to if you want. But I need to know the app, because if the app was incorrectly implemented and it has really big errors in it, then you need to be able to point to that, right, and say it was the app's fault. Of course, you want to always try to find the most accurate app you can find, especially if you're working in industry. But that would be an example. If you use a handheld GPS, tell me what you used for that. If you used a mobile mapping system, tell me that you used a mobile mapping system. So always, always, always state the equipment. So you need to say the date, the equipment, and the name of the person who collected the data. So if it was just you, it's like self-collected. Very easy to state. If you had a partner, it's like, this person and this person collected the data. Okay, so feel free to include your partner's name when you go out into the field to collect, because they have just as many rights to that information as you do. So really important. I don't know how else to emphasize this part. Not only do you need to source anything that was collected from somebody else or used in the creation of the map, but you also need to state what you did yourself. Okay, so that's really important. And that goes on the map. It doesn't go in like the report that might be attached to it. It doesn't go in some other document. It goes right on the map. So the next, the next thing that you need on your map is a scale bar. So we talked about scales way back. So you're going to have a scale bar and you're going to have a scale ratio. I need to see both of them. They should not be some weird wacky number. So you will see sometimes, especially in ArcGIS, that the scale bar shows up in degrees. That is really hard to conceptualize. Nobody knows what 6 degrees is on a map. So make sure that it's in meters or kilometers. The scale ratio should be 1 to some number. And sometimes in ArcGIS it will go 1 to 0. And that just means that the data frame coordinate system has not been set. So just make sure that that has been set. Then there's a map projection. You're going to tell me what map projection you're using. Why? Because we just finished that module. It tells me what errors they're going to be in there. It tells me if I'm going to be using the mathematics on it, like any measurements. It tells me what I need to do for scale ratio. It tells me the distortions to look for. It tells me whether it was really an optimal thing. It allows for you as well. You have to think, is this an optimal projection for what I am trying to show? So it's important to think about that. Then the ever-loving legend. Everybody loves legends. Make sure it's there because it tells me what each feature is, or different groupings of features. But please change the title of it. I know it's a legend. You don't need to tell me it's a legend. It's like titling your map. That doesn't make any sense. It's not descriptive. It tells me nothing. So legend is where you're going to be more descriptive. So your title is like, local park and varsity. And then your legend is going to say, like maybe the title is collected map features, or like park features for running, or park features for play, or all park features collected in the park. Be very specific. And that is the legend. I don't want to see the word legend. You actually lose marks if you say legend. If I see that word, it drives me nuts. It actually, like, I am smart enough that I know what a legend is, okay? I really do. I know what it is. I promise. I've studied a lot. And you probably know what it is too, because you have studied enough to be able to even get into college. You know that it's a legend. So instead of just stating the obvious, why don't we be a little bit more descriptive and say specifics that maybe are not so obvious? So please change it. I know that other instructors are not very picky about that, but they also maybe didn't study cartography, which is like how to make a map, the science behind a map making. So please be descriptive with that. Don't worry too much about the elements inside. I just want to see that title, the legend title, changed to something more descriptive. All right, then north arrow, include that. You guys should be only using UTM or 3TM for our project, so you're going to include a north arrow because it's all grid north. And then we're also going to have a neat line. So ArcGIS automatically puts in a neat line. You don't have to think about it. It's usually like this black outline of the map. And you're like, oh, it goes into a box. And all it is just an aesthetic thing to keep it like very clean and everything's separated. So I want to see a neat line as well. So to give you an idea, when I go to mark your maps and mark the map element part, it's just check boxes. So every single one of these dots, if you can put a check mark beside it on your map and you're like, yes, that's on my PDF. Yes, that's on my PDF. Yes, 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 yes. That is all your map elements that you need. And that's all I'm looking for. Except for the legend, the title needs to be changed. That one's specific. And the scale bar needs to be in metric and etc. So like the little things, but But really, if you have them in there, you've got it. So it might take you 30 seconds to add all this. It may be 5 minutes. So just take some time to double check that. So I'm going to move into digitizing now. So these are the first two parts of this were data collection and map elements. Now we're going to get into the actual map making itself. So this is digitization. I'm going to discuss a little bit about GIS in this because GIS is really the map making part of our world. There's a lot involved in GIS. So stating that, ArcGIS itself has a way of setting up geodatabases. So this is database management. So the old version of ArcGIS had three components. It had ArcCatalog, it had ArcMap, and it had ArcScene. So when you're going through your map creation, you need to have a database set up that has all the information in it. So, and I guess I should go back and just talk about like what a GIS is. So a GIS is a data management system that allows you to analyze, measure, observe, create spatial relationships between spatial and non-spatial data, and it allows you to develop a layered version where you can actually see these relationships in a visual context. So ArcGIS is like the top GIS software in basically the world, I think. It's used pretty much everywhere I've seen. There are some open source versions of GIS, but they're not as robust and they don't have as much to them as what this does. So we talked about directories. Now geodatabases are set up with directories. We'll have a database name. And so I will be walking you through in other videos and coming videos, the database name, like how you set that up, and then you're going to set up a data set. So in my examples here, I do want you to have like 3 data sets, okay, when you go to do your assignment. And so you're going to set up your database, and then you're going to have 3 data sets. Now the 3 data sets can either be they can be related to transportation, they can be related to shelter, they can be related to rest stops, if you want to call it that. They can be related to activities to do. There's a lot of stuff that you can do with your part or your area that you're going to do a map of. But your data set is like a folder. So it's like there are going to be related material and related types of ground in this folder. So showing here, we have our database name, feature data set, and then feature classes underneath, and I have another feature data set with feature classes underneath. So in an example that from the past, we were doing the SAIT campus, so we would have buildings here. And under buildings, I would have parkades, I would have lecture buildings, I would have service buildings, I would have, I think those are the main ones. So I have those, and then when I go to create my actual features, I would go to that and I would save it in each of these files. The other one would be transportation. So transportation would have parking lots, roads, sidewalks, C-train. So then the C-train would have 2 different kinds of features, right? Because it would have a building and then it would also have the tracks. So those feature classes, that's like a thing on the ground that you can collectively put together. You do not want to have a different feature class for every single feature. Because otherwise, what if you have 1,000 features in one that are related? That's going to take you forever. Right. Also look at points as well, so we can have like natural items as a featured data set. So you could say trees. Maybe there's like groupings of trees. There's an area, for example, at SAIT campus that is all natural, like the Albertan wild plants area. So you might actually like make a polygon around that, right? So Each feature class, a key thing with feature classes, is that they are only of one type. So they can only be a point or line or area. So the feature datasets and classes here for this one, just going back to what I was just saying. Feature dataset is like a subdirectory that holds similar data together, so it's like all related. And the feature class is a file that contains one type of feature, so it can have only points or only lines or only polygons. It can't have anything different. You can't have a building and a road in the same thing because those are two different things. So in digitization, the idea is that you've got this amazing setup of your database, and now you know all of the different features, and then you get to draw features. So a satellite image is nice. I mean, I love satellite images. My background is in remote sensing. I can do a lot with them. But when you're trying to make decisions about things, it doesn't really give you additional information. So for example, I can't use a satellite image and show polling results for like, happiness with a government party or something. I can't do that. I can't show I can't take my images and show the number of trees and with respect to their proximity to the street. Because to do that, that would take a lot of time. I would have to like manually count that. So instead of using satellite images to do all of our information or aerial photos to do all of our maps, we have to actually digitize them. So yes, there are some automated features out there that do allow you to do this quickly. I'm very aware of that. But a lot of times there isn't anything that's actually going to work well. So if you are trying to digitize, you are probably going to have to do something manually. And most people who work in GIS start off by doing a lot of this. So you spend a lot of time digitizing because it's just story of our lives with the GIS. So anyway, so what you're going to do is you're going to draw features from another file. So that means that if you're drawing roads, you're going to click along the road. It's a point and click situation. It is the most relaxing thing you'll ever do until you make a mistake and then you're swearing. But but just go along the road and just point and click. You go around the building and then you double click and done, the building's all done. So make sure when you're doing that, make sure one feature is one symbol. So a building is only one building. There's not several parts to the building that you're going to separate it up unless you have to, unless there's like a reason to do that. You are going to keep all the buildings as one polygon. I don't want to see one building split up into 5 pieces. You also need to take your time and be cautious. So you want to follow the lines. This is where you get really good with a mouse. You need to follow the lines. And so that is another rule with digitization. Always go back and take a look at what you did. Turn your feature on and off so you can actually see below it, or even put a transparency to it to see if it actually matches the previous file. Because if it doesn't, then you've done something incorrect. So so that's digitization. This is a component to the assignment in ArcGIS. So that is yeah, so that's digitization. So we will be, in the next video, I will be covering points, lines, and areas as symbols, and I will get to that in the next video.